All right, well, we'll see how this goes. It's certainly going to be interesting. Okie dokie. So today we will be finishing up our is it working? Our very last lecture on new stuff. And tomorrow we'll play around and do some problem solving and recitation. Also, after class, if you want to see where you stand so that you can either panic or not panic, for the final, just come to my office. I have everything sorted. And I'll try to remember my computer tomorrow so that you guys can check it tomorrow as well.
Will you have it in lab?
I will have it. Vincent. Cooper, sorry.
Well, I was just thinking that you could just have everybody fill it out during recitation or like take time.
If we don't bring our
Well, all right. We'll try and pull that off. The reason why I don't like doing that in class is because we have a lot to cover, and we have a lot to cover today, and we have a lot of problems to work through tomorrow. And if there is time, yeah, we'll go ahead and do that. But, you know, in all honesty, it's about you guys passing the class, to be honest.
Yeah.
And I know I'm asking you to take 15 precious minutes of your life outside of class to fill out my review, but it is what it is. All right? Okay, tally-ho. So, last time we spoke about interference on thin films, and I did a really crude sort of demonstration of our double slit. Get rid of these guys so I don't use them anymore. Let's get this one as an unused alter. Our double slit. And we had some separation D here, and we said, okay, we have two light rays that start off in phase and go off to some distant wall, and they travel off at some angle, theta, with respect to the perpendicular. And the difference in the distance traveled by the two rays of light using trigonometry is equal to this term. And when this difference in distance traveled by the two rays of light is equal to an integer multiple of the wavelength, you get a bright spot. If it's a half integer multiple of the wavelength, you get destructive interference, and you get a dark spot.
Where is the delta L measured? Is it on
It's this. This is delta L right here.
Okay.
So we get m lambda bright and then m lambda, or m plus a half lambda, is dark. But this is the more simplistic way to look at things. And as you noticed from lab, it's not as straightforward as this. There's some other funky stuff going on. And so today we'll talk a little bit about that funky stuff that's going on. And then we'll revisit this in terms of a grading. Now, as far as the funky stuff, can I go ahead and erase this? Cam's still writing, so I'm going to...
Go ahead.
Alright, well, I just want to make sure.
Oh.
Yeah, it's too late now, Cam. Sorry. If we were to look at a single slit, and a really good way to sort of work our way through this is we have our slit separation as being some distance A. And then now let's just say that we'll take two little points of light that are passing through here. So So even though you may have your laser back here and it's sending the beam over here, it can still be approximated by these 2 points, an infinite number of points from here to here, emitting some form of light in phase with one another. But we don't want to deal with an infinite number of sources, or at least not yet, because, well, that gets kind of confusing. So we'll just take the two. And just like with the double slits, you have these two guys traveling to some point on the wall way over there at some angle theta, and if you look at the difference in distance traveled, which would again be this piece right here, well, that difference in distance traveled is equal to, again, A times sine theta. But, I'm sorry, not A, because this is halfway through the slit, so it's really A over 2 times sine theta. If this is equal to a half of a wavelength, you get a dark point, or a dark fringe. So we're only going to deal with dark fringes in this case, because it just gets too messy otherwise. So then, if you look off on your distant wall, this would be the point where you get your first dark fringe. This is, so if you have A sine theta equaling lambda, this is your first dark fringe. Now what we can do is we can add more points to this. So we can take and put one here and put one there so that